If you like this video, please press the subscribe button to subscribe to this channel, and also give it a thumbs up. You can also support this channel with a donation by using the link in the description. Quantum gravity is a general name given to any theory that shows quantum effects in gravitation. They usually involve unifying quantum mechanics and general relativity. They come in two major types: graviton theory and space-time quantization theory. Graviton theory attempts to produce a gravitational particle which has already been called the graviton. Space-time quantization theory is an effort to quantize gravity by quantizing space-time itself. The information universe is a space-time quantization theory, and it beautifully unites general relativity and quantum mechanics. Quantum gravity is a theory that tries to explain gravity on quantum scales. It is an effort to try to explain how gravity interacts with subatomic particles. There are two main theoretical varieties of quantum gravity: gravitons and quantized space-time. Quantized space-time is the concept that space and time are divided into discrete units of space and time. In the information universe, these units are quantum length and quantum time. Space and time cannot be divided into any smaller units than these. One of the many benefits of quantized space-time is the fact that it greatly simplifies much of the math of general relativity. That is because the infinitesimals of calculus ultimately become quantum units. As a result, differential ds becomes a discrete change of delta s. This means that at quantum scales, general relativity does not require any differential calculus and can be done with algebra. This simplification would work on larger scales, but it is impractical to use quantum units when dealing with planetary or stellar objects. It does mean that at its core, quantum gravity is actually simpler than general relativity. Ultimately, it simplifies the math because the calculus infinitesimals are real on quantum scales. It ends any need for gravitons, which is just an attempt to find a force-particle transmission protocol for gravitation. It is consistent with the general relativistic view of gravity as being a result of the curving of space-time. It makes quantum gravity truly consistent with general relativity while working with the mathematics of both. The advantage of an information-based reality is that the quantization of space-time can occur independently in every possible reference frame where needed. It easily prevents singularities by virtue of the fact that volume never equals zero. It also makes it possible to have a maximum density, further eliminating the possibility of a singularity. It means that you cannot extrapolate the universe back to a point of zero size and infinite density. This implies that time zero for the universe had a non-zero size and had a finite density. That size and density can be any size and density of smaller volume than the present, but non-zero size and finite density. The quantization of space-time is a preferred method of quantum gravity to the graviton because it is more consistent with general relativity. This can be done as long as the universe is fundamentally information, because it allows space-time to be quantized in every frame of reference. It is a simple solution that unifies general relativity and quantum mechanics while simplifying the mathematics. Here are the upcoming subjects: what this says about reality, unifying the natural and supernatural, fine-tuning this theory, predictions, how this can be falsified, why this requires God, the biblical connection, is time travel possible, is faster than light travel possible,